Okay, so we're going to be taking it a step further. Last class we did scalar multiplication, where you just took a number and you distributed it all the way to all the elements in the matrix. Now we're going to do matrix times another matrix, okay? So you can only multiply if the number of columns in the first matrix is equal to the number of rows in the second matrix. So remember that your dimensions are row by column, right? We talked about that last class. So if you have two matrices, and I'm doing row by column, so I'm going to put a little subscript so you can visualize what I'm saying. So this one is for the first matrix. I've got a row by column for the first matrix, and I'm multiplying row by column for the second matrix. As long as you write your dimensions in that order, what happens is, as long as these two inside numbers are the same, as long as they are equal, you can multiply them. Okay? So if you write your dimensions out, if your two middle numbers are equal, you can multiply them, and your product matrix, your final answer, will have the dimensions of your first by your last number. So if inside is the same, your product matrix is going to have the dimensions of the outside numbers, basically. Okay? So if I multiply a 2 by 3 and a 3 by 4, I'm looking at these inside numbers. Are those the same? Yes, so I can multiply them, and my matrix for my product is going to be a 2 by 4. Okay? So if I multiply a 7 by 1 and a 1 by 2, will that be able to be multiplied? Yes. When you see how we multiply, you'll see why it comes into this. Okay? But if you want to see it like that, then you can see it like that. Yeah. So then your product matrix would be a 7 by 2. Okay? And then if I do a 3 by 3 and a 2 by 3, can I multiply that? No. So if you can't multiply it, it's called undefined. You just put undefined. Last time, when we couldn't add or subtract, we said not possible. So now with multiplication, we're going to say undefined. So you're going to have to keep the two separate in your head. Okay? Now if I have a 4 by 3 and a 3 by 5, can I multiply that? What's going to be the product matrix? 4 by 5. Okay, are y'all good with that? Okay, so identifying that and knowing if you can multiply it is your first key thing. Okay? The reason we're looking at row and column is because to multiply matrices, you have to multiply the numbers in the row from the first matrix by the column in the second. Okay, so we're going to be doing row by column, and that is why we're looking at row by column for the product matrix. Okay? So, this is where all my fancy colored pens come from. So what I'm doing, I need to look at the dimensions of this. What dimension is this matrix? A 2 by 2. What about my second matrix? Alright, so my middle is the same. So my product matrix is going to still be a 2 by 2. Alright, so what I'm going to be doing is I'm going to be multiplying. If you look, this is my first row, this is my second row. This is my first column, this is my second column. Okay, I'm going to do the same thing on the second matrix. First row, first column, second column. Okay, if I have a matrix, this element right here is my first row, first column number, right? Okay, so that's what I'm going to multiply. First row, first column. Alright, now how am I going to do all that? Because there's 4 numbers. Okay. What you're going to do is you're going to multiply first by first plus second by second. Okay? So what we're going to do is we're going to have 2. I'm going to write this out this first time so you can see what I'm doing. You're multiplying 2 times -1, and you add the product of your two second number. So negative 2 times 7. Okay? I'm writing this out the long way first so you can see what I'm multiplying, but after that, I just do your basic numbers. Okay? Then, I need to look at, this would be first row, second column, yeah? So that's what I'm going to multiply. First row, second column. Okay? So I'm going to do first number by first number. So that means I'm going to multiply 2 times 4 and add second number by second number, which is negative 2 times negative 6. Okay? Y'all follow me for that? Semi, at least?
Okay, so when you split those up, like the first row, you split it up on two different sides. So you put it like why don't you put like 2 times negative 2?
Okay, so you have to do row times column plus row times column. You get what I'm saying? So that's why row times row isn't going to give me this number. Because the way you have to multiply is row by column. So first element in this first row, first element in this first column gets multiplied, and then you add second row, second column. You get what I'm saying? Okay. Alright, so then, now I move on to this. Now this is my second row, first column, right? So that's what I multiply. Second row, first column. Okay? So I'm going to multiply first times first, so 5 times negative 1 plus 3 times 7. Okay, now for this last part, this is my second row, second column. So I'm going to multiply second row, second column. So I'm going to multiply 5 by 4 plus 3 times negative 6. Question. Okay? Two times negative 1 is negative 2. And then I've got plus negative 2 times 7 is negative 14. Then I'm going to clean this up. 2 times 4 is 8. Plus negative 2 times negative 6 is 12. And I'm going to clean this up. 5 times negative 1 is negative 5. Plus 3 times 7 is 21. 5 times 4, 20, plus negative 18. I'm just writing the plus with the negative in parentheses so you can see what I'm doing right now. Should you be able to recognize that that should be 20 minus 18? Hopefully. Okay? But if not, you can write it like this. So my final matrix, negative 2 minus 14 gives me negative 16. 8 plus 12, 20. Negative 5 plus 21, 16. And 20 minus 18, 2. And there's my answer. Okay? Once you get the hang of what you're multiplying, you can just do this in the middle and then your final answer. Okay? You do not have to write the long part out. But if you need that so you can keep track of what you're doing, that's fine too. But I'm always going to do this middle part right here. Okay? So I do that because if you went straight from what I give you to the final answer, I have no work to backtrack. I can't find your mistake. So putting at least this right here allows me to find your mistake to be able to give you some partial credit if you were to mess up. Okay? Do we have questions on that example? Okay. So now we're going to look at the dimensions of this next example. I've got a 2 by 2, and this one is a 2 by 3. Can I multiply them? Yes. What's the product going to be? A 2 by 3. Okay. So I'm going to start with first row, first column. Okay. So I'm going to multiply 1 by 5, which is 5, plus 2 times 8, which is 16. Then I'm going to do first row, second column. So I'm going to do 1 times 6, which is, and 2 times 9, which is, okay, now I'm going to keep going, and I'm going to have first row times what? Third column. So then I'm going to do 1 times 7, which is, plus 2 times 10, which is, y'all okay? Okay. Yes, ma'am.
So what's the point of doing like first row column?
Say that again.
What's the point of doing like first row column to get the A, to get that row?
First row times this column, first row times this column, first row. I mean, you can do whatever order you want. It just, to me, is easier to stick with one row, column, 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 and then do second row, column, column, column. Because either way, you're going to have to do row by column. So I don't like to do row 1, column 1, row 2, column 1. I like to go all the way through and then start on row 2. It makes it easier for me in my pattern. If you would rather do column, 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 then that's up to you. Okay?
So we're basically combining the two
You're taking each element from the row and the column, and you're adding the two products of your two numbers. So like if you had a 3 by 3 times a 3 by 3, you'd be doing number times number plus number times number times plus number times number. You get what I'm saying? So you would be doing all 3 numbers times all 3 numbers.
So the second part has to be columns?
Because when you multiply matrices, you have to do row by column. That's the only way you can do it. You do the row of your first matrix by the column of your second matrix. Okay? Okay. All right, so now we've done the whole first row. So now we're going to move to the second row, but then repeat all these columns. So second row, first column. So I've got 3 times 5, which is 15, plus 4 times 8, which is 12. So then I'm going to do second row, second column, 3 times 6, plus 4 times 9. So then, second row, third column, 3 times 7, plus 4 times 10. So then 5 plus 16 is going to give me 6 plus 18. And 7 plus 20. 15 plus 32. 18 plus 36. 21 plus 40. Okay, are we at least halfway getting it? If we're not all the way there? Okay. Do we have questions? All right, so we're going to figure out we were already figuring out if you could do it. So now we've got what type of matrix? 2 by 2 and a. So what's my product matrix going to be? These do not have to be this big. It's going to be the same thing we've been doing. Okay, the first two examples, same thing we're doing. Okay, so I'm going to do first row times first column. 1 times 5 plus 4 times 9. Okay, then I'm going to do first row, second column. 1 times 7 plus 24. And then second row, first column, 3 times 5. And then I've got a -2 and a 9, so that's going to give me a -18. So then 3 times 7, -2 times 6. So then 5 plus 36, 7 plus 24, 15 minus 18, bless you, 21 minus 12. Thank you.
You're welcome.
Okay, we good? Okay, now here, what are my dimensions? And then here, 3 by 1. So can I multiply it? So what's it going to be? A 2 by 1. Okay. So remember, if you keep the idea of row times column, it doesn't make it as confusing. Even though this seems weird, a 2 by 1 seems weird, but row by column. Okay. So I've got first row, my only column. Okay. So I'm going to have to multiply all 3. Okay, so 2 times 3 is plus 0 times -1, and then -1 times 4. So what you did, but just you're adding one more. Okay, and so now I'm going to do second row times that only column. So 1 times 3. I got a 3 and a -1, so that's going to give me -3. And then 5 and 4 gives me 20. So 6 and -4. 3 minus 3 plus 20. Okay, so here, so what's the dimensions here? This one? This one? We're about to do it. Yeah, we're about to figure that out. So this is a 3 by 2, and what is this? 3 by 1. So can I multiply it? So what do I write? Undefined. And there's no work to be done because you can't do it. Okay? Does that answer your question? How that was undefined? So that question goes with this matrix. You see how it's undefined? This one? So that goes with this. So your column for your first matrix and the rows for your second matrix have to be the same number. So see how when we write these, those inside numbers are the same? And so that is what allows this to be able to be multiplied. Whereas here, my two inside numbers are not the same. I can't do row by column, and it end up working out. No. This goes with, it's kind of talking about the matrix right underneath it. So the undefined is referring to this matrix underneath it. Does that make sense now? Okay. Maybe I should add the word below. Is the matrix below defined? Maybe that'll help. Okay. So here, what are my dimensions for 1, -1? A 1 by 2. And what are my dimensions for the second one? All right. So then, what am I going to end up with? One number. Okay? So, row times column. 1 and 3 gives me 3. -1 and 9 gives me -9. You good with that? Okay. So now we have a 2 by 2 with a 2 by 3. Can I multiply it? What's it going to turn into? Do y'all want to try this one on your own? See if you can give it? Okay. Are we good? Okay. So when I multiply first row, first column, what should I get? Okay. And then what's my next one? And my next one? Very good. Okay, and then second row? And then? And then? Very good. Were y'all good with that? Okay. So then my final answer? So not bad. I don't think it's really that bad once you get that row by column. Okay, so now if I give you the matrices, now we're just looking at what we need to multiply, okay? So here I've got A times B plus C. So remember, you have to set up your matrices first. You cannot skip out on that. So I'm going to have 4, 3, -1, -2, into 0. B, -3, 1, 0, -2, plus 1, 4, -3, -1. Okay, now I know that it's our first habit to distribute, but we're not going to do that. Okay, order of operations tells me I do what's inside parentheses first. So I'm going to add these two matrices first. Okay, so that tells me I'm going to recopy my matrix A. And I'm going to multiply it by now my sum of those two matrices. So -3 plus 1 is -2. 0 plus 4 is 4. -1 minus 3 is -2. And -2 minus 1 is -3. We good with that? Okay. So what I'm doing in the notes is what you're showing when you do it independently. There's no skipping steps here. Okay? So even though you can look and add these together and then just write this down, you might be able to do that in your head, but we're not doing that on our papers. Okay? We're going to do our setup, and then whatever step we did, we're going to show that and copy the rest down. Now our last step is to multiply them. And can I multiply them? Yes, because I have a 3 by 2 and a 2 by 2. Okay? So 4 times negative 2 is going to give me negative 8. And then I'm going to have a 3 and a negative 2, which gives me negative 6. Do I still need a circle for some of y'all? Or are we good? Okay. So then I'm going to do 4 and 4, which gives me 16. And 3 and negative 3, which gives me negative 9. Negative 1 and negative 2, 2, and then plus 4. And then negative 1, 4 gives me negative 4 plus 6. Two times negative 2, negative 4. Then I'm going to have a 0. You can write the 0 or you don't have to. Okay? And then I'm going to have 8. Again, you can write the 0. You don't have to. So then negative 8 minus 6 gives me negative 14. 16 minus 9. 2 plus 4. Negative 4 plus 6. Negative 4 and 8. We good? Okay. So then AB minus AC, we're going to set it up. Okay, can I multiply A times B? Yes. So underneath it is where I'm going to do that middle part. So I'm going to have 4 times negative 3, which is negative 12, plus 3 times 1, which is 3. And then I'm going to do 4 times 0, which is 0, and then 3 and negative 2 is a negative 6. So if you need to put the 0 minus 6, you can. You don't have to put the 0, though. Okay, then negative 1 times negative 3 is 3, minus 2. Then we're going to have, Yes, so I'm going to multiply this and bring it down, then I'm going to multiply this and bring it down. And then I'm going to subtract. Because my order of operations is telling me multiplication first. Okay, so then I've got 0 again, and then a positive 4. And then I have a negative 6 with 0, and a 0 with a 0, so that's just going to give me 0. Minus, and I'm going to go ahead, before I even clean that up, I'm just going to go ahead, I'm in the multiplication process, I'm going to go ahead and do it. So 4 times 1 is 4 with a negative 9. Then I've got 4 times 4 is 16 with a negative 3.
Wait, how did you get negative 9? Shouldn't it be 3 times 1?
I've got 4 times 1 and then 3 and negative 3.
I did it, yeah.
Okay. So now second row, negative 1 times 1 gives me negative 1. And then negative 2 and negative 3 gives me positive 6. Then negative 1 times 4 is negative 4. Negative 2 and negative 1 gives me positive 2. Two and 1 gives me 2. 0, negative 3 gives me 0. Two and 4 gives me 8. Then I got 0. Okay, so negative 12 plus 3 gives me 0 minus 6, 3 minus 2, 1, then you got 4, negative 6, 0. Minus 4 minus 9, negative 1 plus 6. Oh, I started going down, sorry. And then 2, 16 minus 3, 13. Then negative 2 and 8. Now we subtract negative 9 minus negative 5. Be careful with that, okay, because you're really doing negative 9 plus 5, which is negative 4. Negative 6 minus 13, negative 19. 1 minus 5, negative 4. 4 minus negative 2, 4 plus 2. Negative 6 minus 2. And 0 minus 8. And we're done. Okay, y'all okay with that? Where? This one? You got negative 9 minus negative 5. So that turns into the positive. Okay, do we have any questions other than that? Y'all are good to do your worksheet? Okay, so remember your quiz is over basic operations and multiplying. Okay?